In the quadrilateral PQR, the angle P is equal to 120 degrees. What is the size of the angle Q? The figure may be shown to be a parallelogram. Similar marks on opposite side show that they are equal. So here we have the marks that show that these two sides are equal, marking each side with a single dash and two dashes on this side, so we are sure that these sides are equal in length. The sides equal in length are marked in the same way. Notice that two sides have a single dash on each of them. They are equal in length, while the other two sides have two dashes each. As much as opposite sides of a parallelogram are equal in length, opposite angles are also equal. Angles R and P are equal. Each is equal to 120 degrees. Their sum is therefore 240 degrees. So these are the two angles that are opposite to each other, and we are going to add them. This one is 120 degrees, this is 120 degrees, because opposite angles of a parallelogram are equal. The interior angles of any quadrilateral all add to give 360 degrees. Take away 240 and the remainder will be shared equally between the other two angles. Notice that we are saying the inside or interior angles of a quadrilateral add to give 360. Only four-sided figure this is true for. We also know that the interior angles of a triangle will add to give 180 degrees. So then, if the two angles that we have right here, P and R, each equal to 120 degrees, we add them, which is 240. To find the angles that remain, we subtract 240 from 360, and that is going to give 120 degrees. The remainder of the 120 degrees will be shared equally between the angles T and Q, because opposite angles of a parallelogram are equal. So these two are also equal. Therefore, the 120 is to be shared equally between T and Q. So 120 divided by 2 is equal to 60. The size of the angle Q is therefore 60 degrees, and this is represented by option A. John ate mangoes. He hid himself and ate another 15. Which expression represents this information? So this problem has two simple informative statements that are set up for easy solution. Highlight the first one. John ate mangoes. Write down the number of mangoes that John ate. M. He hid himself and ate another 15. If he ate another 15, the 15 should be added to M, because he ate an additional 15. The information shows that he ate M plus 15 mangoes, and this represented by option C. Seven times a number n increased by 20, and the result is 50. How is this represented mathematically? Let us extract statements from the problem and write down its algebraic representation step by step. 7 times a number n. 7 times means multiply, and this does not need much explanation. Write 7 multiplied by n in algebra. It is more appropriately written as 7n. Increase by 20, that's what that statement is saying. The result is then increased by 20. Students should be mindful of the difference between increased by 20 and 20 times. In this case, the result increases by, gains or goes up by an additional 20. So 20 is added. The result is 50. The next statement says that the result is 50. The previously developed expression is then equated to 50. How is this represented? The answer is option B. What is the value of 2a plus 3b minus 4c when a is 5, b is 6, and c is 7? Write down the initial statement of the problem. There we have 2a plus 3b minus 4c as indicated right here. Now we need to substitute the values of a, b, and c in their respective positions in the expression. So a is equal to 5. B is equal to 6. C is equal to 7. At this early stage, students should get accustomed to the fact that when numbers precede an expression in brackets, the intended arithmetic operation is multiplication. So we have 2 before this 5 here. It means 2 multiplied by 5, and this means 3 multiplied by 6, and this means 4 multiplied by 7. And of course, we need to remember our multiplication table. 2 5s, 10, 3 6s, 18, 4 7s, 28. Very good. So add 10 and 18. 28, subtract 28. So 28 minus 28, and the result is 0. The correct answer is option D. Which represents a number q increased by the same number q? The answer would be a number q added to another number q, and this is represented by option A. Option B represents a number q multiplied by another number q. That's not right. Option C represents a number q subtracted from another number q. That also is incorrect. And the one that is some great distance away is option D, which says a number q raised to the power of another number q. What is the mean of the numbers 14, 20, 28, 35, and 38? What is the mean? To find the mean of the entries, we add the entries and divide the result by the number of entries. So there we have the sum of them, and when we add them, the result is 135. So how many entries do we have? So count the number of entries. And Jerry, remember our little counting exercises that we have gone through? This is one of them. So see if you can catch the numbers before they disappear. Oh yes, Jerry, you would have caught every single one of them. And we have 5 of them. So the number of entries is 5. We therefore divide 135 by 5. So let us first attempt to divide 5 into 1. We cannot. So let us then say 5 into 13. And that will go 2 times and remainder 3. See, 5 into 13, 2. 2 5s, 10. 13 subtract 10 is 3. The answer is 2 and the remainder is 3. So what do we do with that remainder? The remainder 3 will then accompany 5 and we'll say 5 into 35. So the 3 will accompany this 5 here. And we say 5 into 35 and the answer is exactly 7. The answer is 27 and this is option C. Erica has 3 times as many apples as Marcia. Together they have 40 apples. If the number of apples that Marcia has is A, which statement represents this? By examining the statement of the problem, the first thing that we need to highlight is the number of apples that Marcia has. And the number of apples that Marcia has is A. So let us write down that A. Erica has 3 times as many apples as Marcia, or 3 times as many as A. Erica therefore has 3 multiplied by A, or 3A. We will place 3A before A in order to maintain the form that is indicated in the options. So remember that in the options that we have here, we have the 3A coming first, so we'll put the 3A there. Together they have 40. What does together mean? When we put them together, when we sum them, when we add them together. So the next statement says that together they have 40. Putting them together will mean that we add and the result is 40. The answer is option A. 20 diners like crabs, 15 like beef, 25 like pork, and 20 like fish. Which table correctly represents this data? So 20 diners like crabs. So we're going to look in the table in the crab section so we can find 20. 20 diners like crab. Let us highlight the table that confirms this. So look in the crab section and where we see 20, that's the one. Right, so we have those in table C and D. Notice that crabs 15, crabs 15. So this and this are our correct response. 15 like beef. So 15 like beef. Let us also highlight the tables that demonstrate this. Only one of them. Therefore, we need not look any further. So we do not need to check the other dishes that the diners like. We can see that the only table that is true to the information given so far is table D. an NBA star scored 18, 12, 22, 12, and 20 points in 5 consecutive playoff games. What is the modal score? Although this step is not necessary for finding the mode, arrange, that is, sort the numbers, preferably in ascending order. So we have them sorted, with the smallest going first and the largest last. The mode is the entry that occurs the most times. In this case, only 12 occurs more than once. It is therefore the one that occurs the most times. The correct answer is option B. Same situation, but the problem is different because the question is different. What is the median of the set of scores? It is not impossible to determine the median of a set of scores without first sorting them. However, the scores will have to be treated as if they are sorted. To avoid an unnecessarily awkward situation, arrange the numbers, preferably in ascending order. So there we have them in ascending order. The median is the score that falls in the middle of the sorted list. It is obviously 18. However, we may strike off pairs of scores beginning at both ends until only the middle one is left. So strike off those two, then strike off another pair, right? And then the one that is left is 18. It represents the median score. And of course, the correct answer is option C. The mean of 4 numbers is 12. The number 9 is taken out of the set. What is the mean of the other 3? Let us first find the total of the 4 items. This is done by multiplying the mean, which is 12, by the number of entries, which is 4. The sum of all the entries together will be 4 multiplied by 12, which is equal to 48. The number 9 is taken out, so subtract 9 from the total. 48 minus 9 is equal to 39. 39 is the sum of the remaining 3 entries. So we have this sum of the entries. Now we need to divide by the number of entries. To find the mean of the remaining numbers, divide the remaining total, which is 39, by the number of entries that remain. So how many entries remain? If we had 4 and we take out one of them, we are going to be left with 3. So 39 divided by 3 is equal to 13. The correct answer is option A. The graph shows the time spent by 2 boys studying. What type of graph is used to represent the information? The graph has vertical bars, so we are sure that it is a bar graph. There is a special type of bar graph called a histogram in which consecutive bars are joined. We are sure that the graph is not a histogram because the separation between some bars that can be clearly seen. So there we have separation between bars as indicated by those arrows. So we are sure that it is not a histogram, but it has bars. So we are sure that it is a bar graph. The answer is option A. Every student knows that the graph is not a pie chart. A pie chart is a proportional chart that is circular. So the pie chart is circular. It is all well and good to say that the graph is not a line graph nor a pictograph, but it will still be better to give examples of each. So there is your circular pie chart right there. That's an example. And of course, I'm sure that you like those nicknames that are in the pie chart, Jerry. Mighty Mouth, JF Mills, Goat Kid, Chew Fine. Jerry, what does JF Mills mean? I bet you cannot tell me what JF Mills mean. Yes, Jerry. JF Mills means Jamaica Flora Mills. He is nicknamed Jamaica Flora Mills because in the bun eating competition, he uses his mouth to mill the flour that the bun is made of. Something like what you would have done, Jerry. So that is your pie chart. There is your line graph with the line that connect points. It shows our quantity changes values over a period of time. The value of the quantity at any point in time may also be determined from the graph. And of course, this line graph has how many lines? 2 lines. The graph shows the time spent by 2 boys studying. That's the same problem that we have there. What type of graph is used to represent the information? And we have concluded already that it was done with a bar graph. So this that we have right there is an example of a pictograph. A pictograph has pictorial representations of the symbols that it intends to depict. For example, in the one above, a miniature church is there representing 20 churches. The graph shows the time spent by 2 boys studying. Which statement is true? We have all the statements there. First, take a look at the key to the graph. There we have it. John's bars are dotted and Jerry's are the black ones. Read statement A and take a look at the pair of bars soon to be highlighted. So what is statement A? In every month, John studied more hours than Jerry. Jerry's bars are black. That is not true. John is not studying more than Jerry right here. As a matter of fact, statement A is not true because we have found at least a single case in which Jerry studied more than John. So John did not study more hours than Jerry in every single month. There is one that we have here in which Jerry is studying more than John. Now we are going to answer this question, which is, which statement is true? Read statement B and take a look at the pair of bars soon to be highlighted. So statement B, in every month Jerry studied more hours than John. Is that true? Well, here we have John studying more hours than Jerry. Statement B is not true because we found at least a single case in which John studied more hours than Jerry. And we are going to check another statement, statement C. So we're going to read statement C. John and Jerry studied for the same number of hours each month. Is that true? Statement C is not true because we have found a pair of bars in which the number of hours studied by the boys are different. As a matter of fact, there is only 1 month in which the students study for the same number of hours. So let us read statement D and take a look at the pair of bars soon to be highlighted. There is at least 1 month in which John and Jerry studied for the same number of hours. We have found a pair of bars that proves that the statement D is true. So we have a month in which they studied for the same number of hours. So option D is correct. The graph shows the time spent by 2 boys studying, and this particular question is, how many hours did John spend studying for the 4 months? So find the number of hours that John studied each month. January. So for January, you take John, and we have it right there, 20, March, 50, April, 40, May, 60. Then we find the total. Of course, let's see if we can find the total in an easy way. 40 plus 60, 100, and then we have 70 there. 170 hours. The answer is represented by option B. A regular die is rolled. What is the probability that a number is not a 6? Probability again. Recall the formula for probability. Probability is equal to total number of events that will give a favorable outcome over the total number of equiprobable events. So we need the probability that the number is not a 6. The die has 6 faces. Only one is a 6. Therefore, there are 5 other faces that are not equal to 6. The number of faces that will give us a favorable outcome is equal to 5. With the 6 faces, each of which has an equal chance of being selected, the total number of equiprobable events is therefore 6. The probability of not selecting a 6 is 5 out of 6, which is 5 over 6. And this is option A. So 5/6, and this is option A. The graph shows the amount of potatoes in thousands of pounds produced by Mr. Joe in the year 2007. What was the amount of potatoes in pounds produced up to the 20th week? Weeks are located on the horizontal axis of the graph. Find the week, which is 20. So week 20 is the one that is the week in question. So find that. Right. Draw a dotted line from that point vertically upwards to the line of the graph. So this is the line of the graph. This is the line of the graph, and we are going to draw a line vertically upwards till we get, that is from 20, till we get to the line of the graph. What do we do next? Draw another dotted line over to the mass axis. The figure on the mass axis is 15. With the graph showing the mass in thousands of pounds, we are sure that the amount is not merely 15, but 15,000 pounds of potatoes. And this is represented by option B. We have our same situation. The problem is different. What is the total amount of potatoes in pounds produced over the period of time, that is, over the 50 weeks. The total amount of potatoes will be associated with the largest figure at the end of the period. The 50th week is the largest time figure on the graph. Draw a dotted line from that point vertically upwards to the line of the graph. Draw another dotted line over to the mass axis. The figure on the mass axis is 30. With the graph showing the mass in thousands of pounds, we are sure that the amount is 30,000 pounds, and this is represented by option A. We are on that same graph, same situation. Then the final question is, approximately how long did Mr. Joe take to produce 10,000 pounds of potatoes? Now we are on the pounds. Mass is located on the vertical axis. Find the amount in question. Do not forget that it is in thousands of pounds. We need to find 10. Draw a dotted line from that point straight across, that is a horizontal line, to the line of the graph. Draw another dotted line vertically downwards to the weeks axis. The associated week is 10. The associated option is A. The table shows the number of persons in families. How many families were involved? That's easy. There is a column showing the number of families. Find the total of the numbers in that column. The total is 45, and this is represented by option D. The table shows the number of persons in families. What size family represents the mode? What is the mode? The mode in a data set is the entry that occurs the most times. The highest number of families is 12. See, we have here number of families. We have the highest number is 12. Look across to the number of persons associated with the largest number of families. The arrow goes to 4 persons. This represents the mode. The answer is therefore option B.